So I've been asked quite a bit this morning. Well, we've been chatting about knife edge geometries and how they act and what you're kind of looking for in an edge for various tasks. So obviously a kitchen knife is going to need a different kind of edge to a chopping knife or to a machete or an axe. So we don't want to end up in a case where we've got a kitchen knife's edge on an axe, because it just won't work. Work for one or two chops and then your edge will chip out or be screwed up, that kind of thing. So, and it'll be dull almost instantly. So I was asked about edge thickness, what it should be before you put your final edge on. So from your grind, what kind of edge thickness are you looking for? And the answer comes down to, it all depends on the application. So knives that require a keen slicing edge, so like kitchen knives for example, they're going to need a really thin edge, almost we call a laser edge kind of thing. Very thin edge. They're designed for slicing, no heavy work. The edge itself isn't getting much side to side forces, so it's not needing a lot of rigidity or stability from the backup material, so the material that's behind that edge. So in a case like that, you're looking at kitchen knives and you're looking at around, for me, anywhere between about 0.1 to about 0.25 mils on edge thickness before you sharpen and before you put your final edge bevel on. So it'd be a secondary bevel. Whereas for something that's like going to be EDC'd, depending on the size of the blade, so a small blade, you're looking probably at around 0.35-ish to about 0.4 for a small blade, and then all the way up to about 0.65 for a fairly large blade is what I'll do. And what's nice about that is, as an EDC blade, so something like I'll carry with me, or something like you can see in the thumbnail for this video, that's got, I think, if I remember correctly, a 0.5 mil behind the edge, and that gives me a lot of stability behind that edge. So I have a lot of room for error when it comes to use, and that also means that the way I did the edge, which is a flat grind and then it goes into a convex edge, it's a very stable edge. So not only does it cut really well and hold a good edge, but the edge isn't flexing as much. Just in a use point of, say, cutting some wood, because of the geometry of the edge being like that, as a convex, it's a very rounded edge, so then it's obviously a lot stronger, and that also allows for less deflection, which in turn allows for less chance of that edge chipping out. Now, if I were to push the blade too far, it would obviously chip out, but for what I'm doing with it, and general everyday tasks, it's more than enough. It slices really well. I've used it in the kitchen. I've used it to do some carving, some wood carving, and I haven't had an issue yet. It'll open boxes and everything as well. It has cut me plenty times just in use, so it will slice. But it holds that edge really well as well, because that's also what you want as an EDC blade. You need enough meat there that it's going to be holding an edge. Now, sharpening angles is something I'm not going to get into right now, but I wanted to get more into edge geometry and how edge geometry plays into the way the blade functions, how it chops, how it holds an edge, and the general notion, and I've seen tests done. I've like personally seen them done where people will take 2 or 3 knives and have the blades ground in a different way. So we'll have like one flat ground, hollow ground, and convex ground, and then the edges you can vary on the fly. So it'll either be a flat edge or a convex edge. And I will say that a convex blade with a convex edge cuts like nothing you've ever seen before for the widest range. A hollow ground blade with a convex edge cuts stunningly for most tasks, up to about the height of the grind line. So, because at that point you've got a corner, and that increases the resistance in the cut. So if you're cutting anything thin, like narrower than the grind line is high, or anything shorter than the grind line is high, that blade cuts beautifully, and it really does. It slices through things nicely, but in turn it has a weaker edge. It has a weaker blade because there's less material there to support that edge. Giving it a convex edge helps a lot. If I were to do a flat edge, it would be it doesn't cut as well. It can still cut very nicely, again to about the height of that grind line. Yeah, so to about the height of that grind line, it cuts really well. But it's not as nicely supported with a flat edge as it is with a convex edge. A convex edge also holds its edge better, so it'll just last longer, which is what I give to all of my knives that I make. It holds a better edge, and it just looks really nice too. They call it a Moran's Appleseed edge as well, in case you're wondering. The other thing I've seen tested is a flat ground blade with a flat edge, flat secondary bevel is what I mean by edge. Yeah, I'm gonna stay here. And they perform very well. Flat ground blades for me is what I do. It seems like a really nice in between. For cutting performance wise, it slices through and gets through things better than a convex does, but a convex holds its edge like nobody's business. Convex ground for the whole blade, including a convex edge. It's almost so a flat ground blade, I'm not talking zero ground, flat ground within a convex edge, which is what I do. They cut beautifully, they hold an edge, and what's nice is that at the edge, the actual edge, the thickness behind the edge is at a really nice thickness, and it just gets through material really well. There's very little obstructing it as it cuts through anything, so nothing really gets in the way of the cut, unless your bevels don't go all the way to the top, to the spine of the blade. In which case, obviously, then you got the same issue with, but less pronounced of an issue as you would with a hollow ground blade. And that's most of my only reason why I don't do a hollow ground blades, other than I feel that they don't look right on a forged blade. But that's for another video. So I don't know if there's anything else I need to cover. I think that's about it. What is that truck doing? Looks like somebody may have broken down. Not sure. Is it? I can't tell. Does the truck have hazards on? Okay, so it's just being special, I guess. Anyway, so yeah, edge geometry plays. It's probably one of the most important parts to the knife. My purely because that's essentially the business end of everything that's happening with the blade. The cutting edge is where the person meets whatever they're cutting, obviously, and that defines how the majority of people will kind of evaluate your blade. So if your cutting edge doesn't, if the blade doesn't hold a good edge, they're going to say it's terrible. It may be down to, it may not be down to your heat treat at all. It may be down to how you've shaped the blade, what kind of a grind you've got, how you've shaped the edge, how thick it is behind the edge, how much stock you've got there that supports that edge, because that's very important. For anybody who's seen a screwdriver isn't tiny and thin when you need to open a big bolt. It's a wedge. It's got a lot of strength at the tip, at the edge of that wedge, because it's got a lot of mass behind it. There's a lot of meat there. That thing on fire. Grief. It's an interesting drive. So there's a lot of meat there. It supports that edge, the edge of the screwdriver. So it's the same for a blade. You need that mass there. You need that stock there. There needs to be something there to support that edge. You can't use a razor blade to chop into wood because there's nothing supporting the edge. But you can get a massively fine edge on a razor blade because there's very little in the way to get in the way of the hairs and everything. So you're going to be shaving. Let me just go here. Unusual to see a traffic cop. So you've got to design that to the design of your blade and the intended use. Again, you're not going to use a straight razor to chop down a tree, and you're not going to use a.
That's one bad accident.
Yeah, that is a bad accident. I wondered why there were traffic cops running around. So you're not going to use a machete or an axe to shave. I mean, you can get the edge to a point where it could, and you could try chop down a tree with a straight razor, but it's just not going to work very well. Yeah, so you've got to design your edge to being your edge geometry to working with the intended use, the intended application and design of your blade, and you've got to work the actual style of edge. We're talking between a flat edge and a flat secondary bevel or a convex secondary bevel. You've got to tailor that to the intended use. I'm not going to put a convex edge on my campus now. There's people that just park in the middle of a road without their hazards. I'm not going to put a convex edge on a razor, firstly because it's really difficult to do, and at the same point it's not really necessary. I'm needing that really, really fine edge. It must be as fine as possible, and doing a hand ground convex on something like a razor where it needs the precision just isn't very manageable on a scale that I'd be able to do. Yeah, so let me just get it here. Oh yeah, they fixed the thing. Yeah, so I'm about to park. That's kind of what I'm going to get into for this video. I may follow it up if I find that people have got questions. I don't know if I've covered everything. I highly doubt it. But at some point I'd like to do a video, maybe testing some of the edge geometries. My buddy Calvin check out his page. It's damn, what is it? It's CKK, I think. Calvin Custom Knives, yeah. CKK Knives. He's, I think, on Instagram. Yes, I think he is on Instagram. So check him out. We were chatting about this, but he would like to see at some point a video demonstrating 3 of the same knife, same heat treat, with different grinds. So a convex, a hollow ground, and a flat ground blade. And then on each of those we could put the different edge styles, so a convex or a flat. And we could test them, and we could see how each one performs individually, how it all works together, and what it ends up doing. And I think that might be worth doing at some point. So I'm going to call it there. I'd like to do that. I don't know if I'm going to get time to be able to firstly make the knives, let alone test them. But maybe I can work with somebody on that, and that'd be cool. Anyway, guys, hope you have a great day, and chat to you soon. Cheers.